Hello and welcome, all you new people. I saw the raid take place and I decided, heck, I would turn on the stream a couple minutes early. Just to welcome you and tell you what you landed on before I start our full episode. This is the home of CosmoQuest X. We are a project dedicated to putting science into your brain. Every day, Monday through Friday, I or one of our other staff members bring you the news. So we're going to have 15 minutes of science news, and then I'll stick around to answer any questions you all might have. So welcome. Remember, follows are free. If you like what you see, go ahead and click that button so that you'll get notifications next time we go live. So now I'm going to go ahead and get started with our regular show. Hello and welcome to the Daily Space for Wednesday, May 16th, 2018. I am your host, Dr. Pamela Gay, and I am here to bring you a taste of all that's new in astronomy and space science. For today's top story, astronomers working at UCL, which is University College London, at Osaka Sangyo University in Japan, have discovered that there were already entire generations of stars that had lived and died by 500 million years after the Big Bang. This implies that we actually started to see the very first stars forming just 250 million years after our universe started. Now, the way they were able to do this is there's certain molecules, certain atoms that we don't expect to see in our universe, well, until a star has died. You and I, we're made of dead star stuff. Not just star stuff, but dead star stuff. Oxygen, like the oxygen we breathe here on Earth, it's produced in stars, including stars like our sun. And when they die, they puff off their atmosphere. And all of that material, first it starts off looking like a pretty planetary nebula, but over time it drifts away and becomes part of, well, the stuff available to become new generations of stars. Now, the system they were looking at with the license plate address MACS1149-JD1, they found that it had oxygen in it, and this oxygen, which could only come from the death of stars, means that there were stars at a super early time. Now, to look at this star, this galaxy, in fact, they had to use the NASA ESA Hubble Space Telescope and then do follow-up observations with the Atacama Large Millimeter Array down in Chile. This particular galaxy is located 13.28 billion light years away. Now, because it takes light time to travel, just like it takes you and I time to travel, we can use the speed at which light travels to work backwards and figure out when we were looking at a system. If we're looking at our own sun, we're seeing an object that is about 8 light minutes away. So we're always seeing the sun as it was 8 minutes ago. When we look at a galaxy that's 13.28 billion light years away, we're actually seeing light that has been traveling to reach us for, well, basically 13.28 billion years. So here we are. We now know that stars formed fast and furious, died young, and gave up their elements to form new generations of stars. And we found it in a pretty picture. You can't beat having science that is intellectually beautiful and, well, just pretty to look at. Now, in completely different news, scientists are now using Dorset, England, shown here as a Mars analog. Now, they're not exactly using this castle or this pub. What they are using is this very acidic stream. It turns out that if there is water on Mars, it is quite likely highly acidic. It is quite likely highly salty. And when you put all these factors together, it means any life that exists on Mars or existed in the past on Mars probably resembled the life we find in these streams in Dorset, England. Now, luckily, not all of Dorset is overrun with acidic streams, but the acidic streams they do have are overrun with life. Not human life, not fish, nothing big and interesting, but rather these streams are chock full of what we call extremophiles. These are often microscopic life forms. They can sometimes grow to be much bigger by forming microbial mats, which is basically a slime layer of many of these critters all grouped together. They are teeming with life we call extremophiles, life that is able to exist in this highly acidic environment. By studying the life that we find in Dorset, England's acidic streams, we hope to understand the kind of life that we'll eventually be able to find, hopefully, we're not sure, on Mars. Now, one of the key things that came out of this is in looking at this particular life, what they found was there are fat deposits in the water, there are complex molecules in the water, and all of these different things, all of these different molecules are bioindicators. They tell us here is life without actually being the life itself. We may be able to find these bioindicators with future missions to Mars. The other thing that caught their attention is the kinds of biological processes and chemical processes that are taking place in this lake are the same kinds of processes that led to the formation of the common mineral hematite that is found all over Mars. Hematite you may recognize as a stone that is used in some forms of jewelry that kind of looks like the element mercury in solid form. It's these little tiny, highly reflective stones. It's a mineral that only forms in water. So when we understand how this extreme life forms on our own planet, it starts to give us a hint of how life might have formed and may still be out in our solar system on other worlds. Now, moving beyond this to revisit a story that we talked about a couple of weeks ago, there is yet more evidence for Michael Brown and Constantine Begier's ninth planet, or 10th planet, depending on how you want to count, or heck, planet in the 60s. However you look at numbering the planets in our solar system, there is evidence that there is a new world significantly larger than Earth lurking out in the outer edges of our solar system. The way that scientists have figured out that this world is probably out there is by looking at the orbits of many small bodies called dwarf planets and Kuiper belt objects. These worlds seem to have orbits that, instead of being nice and circular like our own planet's orbit is, are much more flattened, elliptical. And rather than existing in the plane of the galaxy like most of the planets do, kind of with orbits that looked like an ill-stacked group of plates, these worlds have highly tilted orbits. If you look at how all of these different dwarf worlds have their orbits tilted, it turns out they're all kind of pointing in the same direction. And the only way you can balance having all of these different orbits pointed off in one set of directions is to have another body that counterbalances them in the other direction. Figuring out how all of these orbits work together, it can be worked backwards to determine the expected orbital and physical characteristics of this counterbalancing body. Now, in this particular case, It wasn't scientists out there looking to discover another Kuiper Belt object or dwarf world that made this discovery. Rather, the Dark Energy Survey, which is using a variety of images to look for, well, how our universe is expanding. Through their images, they periodically kick out things that aren't distant galaxies. In this case, a doctoral student at the University of Michigan, Juliet Becker, led the analysis of this new object. The object was found in the imaging done for the Dark Energy Survey, and this team is taking care to leave no science undone. In her work, she figured out that this particular object is orbiting the sun every 1,110 days. Sorry, I said that wrong. So they looked at this object over 1,110 days and were able to determine its orbit from this long period of observations. Now, the reason that you have to look at these distant objects for so long is they move extraordinarily slowly across the sky. You may not be able to detect their movement in a single night or even a series of nights that are closely packed together. We've had this problem before. In fact, it's thought that Galileo may have observed Neptune while he was looking at Jupiter on at least one occasion. But because Neptune wasn't moving quickly through the sky, he failed to notice its movement compared to Jupiter's movement. Now, with this particular very long observational period, she was able to discover that this planet has a semi-major axis. That's the length of its longest elliptical direction. That's about 450 astronomical units. So its entire orbital size from one side of the solar system to the other spans 900 AU, with the center located not in the middle, because ellipses actually get much closer to the sun on one side and much further away on the other. This system has an eccentricity, for those of you who speak geometry, of E equals 0.92. This means it's very, very squished, and it's inclined 54 degrees to the plane of our galaxy, of our solar system, rather. So today's news kind of spans a little bit of everything. We started off with a tale of how we now know that stars started forming 250 million years after the Big Bang. We reviewed how a city in England that might be a cool place to go visit can also be used, or at least its acidic streams can be used, as a Mars analog. And finally, we round out our summary with a bit of news from right here in our own solar system, giving us further evidence for the existence of Planet 9, or whatever number you want to give it. Now, today was a kind of slow news day. This is all I have, but I am here to answer any questions you might have out there in the chat. Thank you for joining me again. My name is Dr. Pamela Gay, and this show is brought to you by CosmoQuest. Visit CosmoQuest.org, where you can get involved in helping us explore our universe. We have a variety of citizen science projects that invite you to map out Mars, Mercury, Vesta, even our own Earth, using astronaut photos. Tune in every Monday through Friday at 1 p.m. Eastern, that's 6 p.m. England, and 11 a.m. Pacific. 10 a.m. Pacific, and we will bring you a news roundup just like you heard today. We have a variety of other content. Follow us on Twitter and catch it all. Now, if you liked what you saw today, give us a follow. Follows are free. This show and all of our other programs here on Twitch are sustained through your subscriptions, bits, and other donations. Thank you so much, all of you who have given to our production. I can't thank you enough for allowing us to, well, put science in your brain. Thanks a lot, and now I'm here to answer your questions. If you can @ me, at CosmoQuestX, it will really help me out in finding out what it is that you want to know. So let me... Oh, I just realized I didn't show you any of the pictures I had today. I am so sorry. I was clicking away to show them all. So this is the place where we have Hubble Space Telescope images that allowed us to discover oxygen in a galaxy far, far, far away, and realize that stars started to form 250 million years ago. Here is Dorset, England, and here is the super acidic stream that they looked through. And finally, here is a plot of the orbit of our newly discovered extra world. Thank you all so much for your patience with me as I failed to switch views. Okay, so I'm going to look and see what questions you have in the chat. Yes, Peter, you definitely shouldn't be drinking the water on Mars. It will not only be a little bit too acidic to drink, but also way too salty to be of use to the human body. So I see Stranghaj is asking, I understand, and I use the term loosely, how one can figure out the side and location of a missing object due to gravitational pulls, but how can you figure out that object structure? It's not, yes, size. So it's a matter of, in order to move, to torque the orbits of the other dwarf worlds, what mass is needed to create the needed amount of gravitational influence. So if this world isn't at least several times the size of Earth, it doesn't have enough gravity to affect the orbits of the other objects out in the Kuiper belt. So Peter, boiling it won't get rid of salt and acid. Some sort of a filtration system will be needed to get the water fully drinkable. And thank you for helping me make sure I always get my time zones correct. So I see Azurian Palin is asking, the new lander going to Mars that will probe a few meters into the surface. This is the InSight Mars mission. If it lands close to a subsurface aquifer, would that make it difficult to understand the readings precisely? It's not crazy vague. I totally understand what you're asking. So the InSight mission, and I may have a photo I can go to. No, I don't. So the InSight mission going to Mars is actually going to send a little probe several meters beneath the surface. The goal is to measure the temperature as a function of depth on the red planet. Now, if there is subsurface water, we would expect it to have slightly different thermal properties than all the rest of the soil around it. It would probably cause the temperature to jump faster, since in general liquids conduct temperature faster than non-liquids. So it's potentially, if it's there, going to allow us to see anomalies that can only be explained if there's something that has thermal conducting properties that are inconsistent with the rest of the soils. It would also probably lead to differences in the rate at which this little probe is capable of burrowing. So by putting together the differences in, well, how hard it is to dig and how quickly temperatures vary, we'd be able to say there is something here that is consistent with liquid. So I see Peter. Yeah, Peter, we could probably use salty, acidic water for cleaning, just probably not cleaning ourselves if we like ourselves. Denizen of Earth, I'm actually going to have to look up that number. It's not too long ago that their paper came out. So this is work again by Michael Brown and Konstantin Buryig, whose last name I'm sure I'm terribly, terribly mispronouncing. Let me see if I can find out when their first paper on this came out. So it was predicted in so 2016 was when they were finally able to say this is where we think its orbit should be. Again, that's work done by Konstantin Batkin. I'm going to just pronounce his name different every single time, and Michael Brown. There'd been earlier work by Chad Trujillo, who often works with Michael Brown, as well as Scott Shepard in 2014, based on Sedna and 2012 VP-113's orbits, they said there could be another orbit out there. So, as always, science builds one paper at a time towards the truth. This is why we science. We don't know everything, but we're trying to get there. Okay, looking back at the chat. So Larry is asking, is distillation easier on Mars at the low pressure? I think it would actually be much harder. If you think about it, here on Earth, we often have gravity-fed distillation columns. These are columns that have a variety of different filters in them, and gravity pulls the liquid through the columns. If you don't have enough gravity pulling down on your liquids, it will take significantly longer to pass through the filters and may simply not. So Uncle Bill, the Planet 9 is suspected by theory at this point. So it's in the same state that, for instance, Uranus was in when it was predicted but not yet discovered. Hello, Sufi. Hello, Susie. Welcome for joining. So other questions out there. So to give you information on other things we're going to be doing here at CosmoQuest this week, I will be back tomorrow with Learning Space as soon as the daily space is over. Matt Richardson, who I'm sure is out there eagerly waiting to take hold of the stream, he's going to be doing his his CosmoQuest Astro office hours, where he'll be here to answer more of your questions, and he's game to even work out the maths behind how we know what we know about different objects. And Automod on here is a bit picky. Thanks all of you mods for your great work in both killing things that need killed and putting into the stream things that Automod really shouldn't have kept. So I see Azurian Palin asking about filtration, but couldn't you make a much larger column to create more pressure? So what you actually want to do is you want to make a much skinnier column that's much higher so that you have a greater column depth, which leads to greater pressure through the system. So it's by making the column skinnier and taller that you can get better results on these lower gravity worlds. Hello, Cosmic Rays, welcome. So tomorrow, as I said, is Learning Space. I will have special guest Pamela Harmon from the SETI Institute to talk about various projects that she's done over the years, including building a young community of astrobiologists and helping get that new profession within our field up and running. She also is going to talk about how they currently create opportunities for school teachers to fly on the Sophia Airborne Observatory. Yes, Azuriel, we can build higher in low gravity and the problem is sort of solved. So since I'm not seeing any further questions, I'm going to go ahead and turn this feed over to Matt. So stay tuned. Yes, Denizen of Earth, this will be the same time tomorrow. So stay tuned. You'll see the feed blink out, and then I will be right back with a new host coming to you from Nashville, Tennessee. So Matt, I hope you're out there and you're ready, because the channel's coming over to you.